Hello. Hi, good morning, everyone.
Good morning.
Good morning.
How are you all?
Good.
Okay. So today we are going to start with PCIe, right? So first of all, let me discuss a few points with everyone so that we can start. Okay. Still anyone there to join, or shall we continue? So if anyone is in lobby, just you can admit, okay? So, okay, coming to the course agenda, till now, a few of the demo sessions are completed, right? So few of the mentors took the demo session and you got the clarity, and we also got the clarity how we need to focus in the next coming sessions, and how you are understanding and what areas we need to focus majorly. So after seeing a few of the demo sessions, according to that, I got some clarity and I did some changes accordingly. Okay. So, first of all, what is our course agenda? You already know, you already gone through the 16-week course curriculum, right? So, we are going to follow exact course curriculum, week 1, week 2, week 3, week 4, same as it is. Okay, no changes in that. Okay, so our main course agenda is the detailed explanation of PCIe from Gen 1 to Gen 6, whatever the features are mentioned in the curriculum, same we are going to discuss weekly schedule. Okay. So I need no need to explain the 16-week curriculum, I think, right? So next, real-time packet flow of PCIe. This is the main important thing. Whatever the curriculum we have mentioned, same. Okay. As a PCIe learners, you must know how the real-time packet flow is working. That is very important. Okay. And debugging techniques of PCIe. So in the industry, how actually the requirement, like if you are going to, you are taking the course for the interview preparation only, right? So to crack the interviews in the next level for the job change. Okay, so we are going to discuss the debugging techniques of PCIe, like the specification wise. Okay, and how the actually industry working with the PCIe. So if anyone or hiring some person for PCIe, they have their expectations, like according to the work. Okay, so our mentors will give you overall idea what they will expect from any of the service based company or product based company, whatever, based on their experience. You will get understanding how actual industry will work. Okay, and how real-time PCIe projects will be there, like how we need to work after getting into the PCIe project. Everything we are going to learn from here itself, how to develop the test cases, how to develop the test plans, how actually the test will be built in the PCIe. Okay, next, interview preparation. Our mentors are very strict with the interview preparation, not just learning the theory. Okay, you need to able to crack the interview, right? So our main focus is like logical way of thinking, how we can solve the logical questions. Service based companies means, okay, if you go to the product based, most of the questions you will get logical, like at least one or two questions, right? So based on that, how you are thinking, at least if you may not able to answer for that question, at least they will check your thinking capability, like how the way you are thinking. Okay, will it be useful for further process or not, whether you are thinking based on the requirement, like that will be major focus, right? So that's why we need to provide in an interview preparation how the thinking capability, if any question rises, how we can able to answer in the way. Okay. And weekly assignments, whatever the topic we have discussed, based on that there will be weekly assignments. You can take whole week will be there, right? You can focus on the spec. I already told you the official mindshare document we will provide to you, and you can go through the specification. Don't depend totally on the mentor sessions. Okay, you need to read the specification. Whenever you read the specification, then only you will get the clarity what actual topic. Mentors are here to deal the understanding point of view. Okay, whatever the doubts you have, you can just simplify the topic. Whenever you read the topic, you may not understand actual importance of that particular concept. Okay, so the mentors will deal how you can simplify the topic and just learn easily. Okay, so everyone need to prefer the specification. You need to read the specification. Okay, next, this is what actual 16-week curriculum. Okay, but as per our previous discussion, I told you we are going to discuss in the application point of view also, right? Banu Teja already discussed one session, demo session. He given some clarity overall how the data processing will be happen with the top level PCIe in application point of view, in embedded system point of view. Okay, so after this 16-week course, I'm going to schedule extra 2 sessions, 2 weeks or 2 sessions for high-speed data secure processing using PCIe and FPGA acceleration. Actually, this is not in our course, okay? But still, I want to give some application point of view, how actually the data processing will be happen, because PCIe is the protocol where we transfer the high-speed data, okay? But how actually it is going to do? Okay, not learning internal hardware. We need to learn top level project in the project point of view also. Whenever the PCI is connected with the different components, how it is working. So that thing also you will be getting in extra 2 weeks after 16 week. Okay. So this is what our course agenda. Okay. So by end of this course, if you perfectly focus, if you utilize the time perfectly, and if you utilize the mentors perfectly, you will get at least 60 to 70% of knowledge from the course. I can't tell 80%, 90%. Even who are working in the industry, they don't know even 60%, 70% also. They just know only 40 to 50%, because PCI is very vast, right? So you won't get, I can't tell everything you will get, but whatever the curriculum we mentioned here, you will get perfect. Okay, so that is what the course agenda. Next, coming to the trainers. Okay, based on your requirement, based on the students' knowledge, I came to this understanding. Okay, so based on that, we have the 4 trainers for PCI. Okay, number 1, Venkatesh. Okay, he having a very good experience in PCIe projects. He is working currently with the Gen 6 and Gen 7 project also. Okay, so he is going to deal with the all PCIe layers, especially Pi layer. Our main focus is Pi layer, right? He also have the experience in data link layer. He will be focusing majorly on Pi layer Gen 6 and Gen 5. He is working in Gen 7 also, actually. So you will get to know some few things, not fully, just a few idea about the Gen 7 also. Okay. And he totally focus on how real-time scenarios works and industry expectations as per the industry. Our main final goal is to just clear the interview. That is our main concept, right? So we are going to deal everything on how we can able to crack from day 1 onwards. Okay, but from your side, the specification is very important. Whatever the concept we completed in the particular week, you need to go through the entire specification of that particular week. Okay, that is very important. And coming to the number 2, Vamsi. So he is dealing with the logical questions. So he is very good expert in like how the interview questions will be asked, not only in PCIe overall. As a DV engineer, he have a good capability of dealing with the logical questions in the interview point of view. And also he have the good experience in transaction layer, data link layer with actual industry, how to build the test cases and the overall frame format, the packet format flow, everything. Okay, so he will also discussing the transaction layer and data link layer. These two are main trainers. Okay, and coming to the third one, Banu Teja, you already know, some of you know, he majorly deal with the application layer. Okay, he is working in an embedded system. He is a software developer in embedded applications. So he will deal with the high-speed secure data processing, how it will be done in the PCIe and FPGA accelerations, and he will give you the detailed explanation of PCIe drivers and use case in the cyber security, like how the one of the use case, how it will be dealt in the cyber security. He is going to give the clarity on this concept. Okay, at the end of the PCIe. Other than these three, another mentor is Vaishnavi. Okay, so if you are a fresher, if you don't know anything about the PCIe, if you are a very starter, like just like you want to learn ABC, if you have any doubts, she will be one of the mentor for you for doubt discussions. Okay, so these 4 mentors are available in any time. Okay, weekdays, weekends, these 4 mentors are available in the group also, as per your convenience. Maybe one, you are feeling good with one mentor, you are comfortable with one person, whether Vaishnavi or Venkatesh, Bhanutej or Vamsi, like that. You as per your comfortable mentor, you can ask the questions and you can discuss. Okay, that's up to you, how the way you are going to utilize this. Okay, because I got 4 mentors and I'm just giving you 4 mentors, you can use accordingly. You can just ask the relevant doubts. Okay, and you can clarify your doubts accordingly. Okay, clear till here? Any doubts?
We can discuss doubt on Saturday, Sunday.
You can discuss doubts on Saturday, Sunday. In weekdays also we have one doubt discussion. If you are just want, if any week, if you are having more doubts, want to clarify, in weekdays also in the evening time at 8 o'clock or 8:30 or 7 o'clock, we'll have some doubt discussion session for 1 hour. If you want
Okay,
more
okay.
clarity.
Okay, thank you.
Okay, so these 4 mentors are available at any time. Okay, even they are very active. They want to give this, they want to make this PCIe successful. Okay, so they are very active and interested to deal with the students, to guide the people. Okay, who are looking from basics. Okay, so you can approach anyone. Okay, and coming to the important points I want to discuss. This course is a 16-week plus, as per the application, it may be 1 or 2 weeks, that is fixed. Okay, we need to follow the weekly wise curriculum. And few important points here. Session should go with the flow as per the curriculum. Okay, whatever the concepts mentioned in that week 1, those concepts should complete in that week, whether it take 2 hours, 2.5 hours, 3 hours. Okay, the concept should complete, and the doubts should be asked at the end of the session only. Others do not disturb, because most of the people are very fresher. You already know, I kept the poll in the meeting, I kept the poll in the group, right? So based on the poll, I understood everyone are fresher. Everyone need to start from basic of PCIe. Okay, they are coming with some focus, like they are coming with their own curriculum, like they are just putting some time, right, to learn something. So because of one or two members doubts, we should not disturb entire session. Okay, so that's why whatever the doubts you get, just note down and ask in the last of the session. You will be getting 30 to 40 minutes only for doubt discussion. Okay, so if it is a simple doubt, just 1 minute or in 2 minutes, if we complete the doubt, you can ask in the middle of the session also, not a problem. Okay, but if the doubts are lagging, if the doubts are going more time, means we will cut the doubts there and you need to ask at the end of the session. You need to follow this strictly. And every candidate should focus on industry point of view, not just reading the spec, not just going the theory. Okay, try to understand what way the mentor is going to discuss, because they have real time experience. I pick these candidates who are working in the PCIe. Okay, only PCIe experience. That means DV plus another projects and PCIe experience. Okay, so try to utilize how they are just teaching, because from their experiences only they will teach, right? So try to understand the mentor point. Let him complete what they are discussing. Don't come in the middle of the explanation, because from last 2 to 3 demo sessions I observed this, right? Because of that, many of the people are disturbing. So don't do that. And every weekend after the sessions, you will get the sessions materials, assignments, you will get your mail. Okay, so don't share these content, official content, to anyone. Okay, so that is what I want to discuss and give clarity today, so that you will focus next 16 week very clearly, because this is not a small DB or just a simple AXI protocol. It's not small thing. To jump into this, first of all, we should have the clarity. Our mind should have some clarity. Then only we can focus on. Because if we miss any session, we cannot go to the next concept. We cannot understand easily the next concept. Everything is interlinked, right? So for that purpose, first of all, your main focus should be there, clarity should be there. Okay, you need to start with a fresh, okay, fresh mindset. Okay, without having any doubts, and clarity. Okay, so that's why I just given the clarity. Write down your schedule, follow the PCIe. Okay, so any doubts still here? No doubts, right? Okay, so today session agenda, Venkatesh is going to start the session today. Okay, so it's a first of all, we will start with the very basics of PCI. Whatever till now completed, just leave it. The demo sessions are completed, just leave it. Even if you understand, don't understand, whatever, start freshly today. Okay, we are going to start from overview, then basics of PCIe protocol, how it is working, and all layers of PCIe. The packet flow is very important in PCIe. Our major focus today is packet flow in the PCIe of each layers. Okay, and then the initialization, how it happens, and Gen 1 to Gen 6 comparison, like that. Okay, and remaining topics of tomorrow as per the week 1 schedule. Okay, so mentor is going to start the session. No doubt should be asked in the middle of the session. If it is a simple doubt, you can go on. Okay, or else at the end of the session, just note down the doubts and ask the doubts. This should be followed by next 16 weeks. Okay. Yeah, Venkatesh, you can start.
Yeah, hi guys. Am I audible? Yes, yes.
Yes, you
Yeah.
are audible. Please share the
Okay.
screen.
Yeah, I will share the screen. Yeah, my name is Venkatesh. Hi, my name is Venkatesh. Currently working as a verification engineer. Okay, I worked on the PCIe and CX protocols. Okay, today we can discuss about the how the basics of PCIe and how the packet flows and how the PCIe data will transfer and how the PCIe will start when any test case is there. Okay, in the real time, how the PCIe will starts. Okay, so
Venkatesh, just a second. Before that, can you give the clarity for these people, like how actually industry will expect and
yeah.
what we need to focus for the next 16 week?
Yeah, basically, as a verification engineer, we need to focus on the PCA protocol first of all on the theory level. Okay, in every interview, they will ask the theoretical questions compulsory. Okay, how the packet flow. Okay, how what are the layers. Okay, what are the features of the layers. There is a certain topics are there. They will ask in the interview. They will ask the theoretical level and also they will ask the real time experience how the test case will flow. As a verification engineer, as a fresher, if it is a fresher, they will ask the theoretical level. No one will ask the RTL level of questions because for even experienced people also they won't get the RTL codes and all because it is encrypted one. No one any company will not share the RTL codes and all any VIP developments. See, you don't think like PCI is like a XR APB. That is the like bus level protocol, but this is the data transfer protocol. So here the VAP development all is a very top level. Okay, no one will ask the VAP development how you developed the VAP of the PCI. Okay, they will ask the packet flow, how the PCI works, and they will ask specifically which layer you have worked on. They will ask on which layer, particularly they will ask compulsory which layer you worked on, either transaction layer, data link layer, file layer. If you're working on transaction layer, they will ask the questions on the transaction layer. This is how the industry will looks like. Like if you know the PCI, they will ask questions on this level. They won't ask the VIP development of PCI and the RTL code of PCI because uh, you as a verification job engineer, job of the verification engineer is to know to debug the PCI cases, test cases. They don't need to code up the PCI. Okay, they need to debug how you are debugging the PCI. Okay, like this only they will ask. Okay, anyone have any questions? Okay, yeah, we can go start the session. Like basically, PCI is the serial data transfer protocol. PCI is the serial data transfer protocol. Before PCIe peripheral component interconnect. Before Express, peripheral component interconnect Express is the PCIe. Before PCIe, we have the PCI. It is a parallel data transfer protocol. PCI is the serial data transfer protocol. It acts as a mediator between the processor and the endpoint. The endpoints are nothing but see PCI acts as a mediator between the processor. Processor means our host, like computer giving the instructions through processor. And endpoint is either graphic cards, USB ports, and sound cards, either like Ethernets and all. These are the endpoints. Mediator is the PCI. Okay? In PCI contain the root complex components such as root complex, switch, or device, or bridge. Okay, like this we have the like this the PCI will works. PCI is the mediator between the two devices. The device is nothing but processor and the endpoint. Okay, we can see the like if the PCI communication happen through link. Okay, see the PCI communication happen through link. For suppose this is the device A and this is the device B. So that the communication between the device A and device B happen through link. Okay, so this line and this line called as a link. A link contain different lanes. If you remember the differential signals in the analog, like in the previously while studying the in academics, there is a differential signals. Okay, plus D and minus D. Through the differential signals, nothing but the wires, the communication will happen. Okay, see, these blue lines are called as the differential signals. Okay, these together, the pair of the differential signal called as the lane. Okay, these yellow highlighted things, the yellow highlighted things are the lanes. Together, lanes are called as a link. So they will, in the interviews, they will ask the what is link. Link is the link is used to communicate between the two PCI devices. Okay, what is lane? Lane contain the differential signals. Differential signals nothing but the wires. Okay, each differential signals we have the plus D and minus D. Okay, they together called as one differential signals. Each differential signal called as a lane. A group of lanes called as a link. This is called as the difference between the link and lane. Through for any PCI devices, the communication should happen through link only. Remember this point, or else note this point. Every PCI devices, between the PCI devices, the communication should happen through link only. So link contain the lanes, either 1, 2, 4, 8, 16, 32, 64. Number of lanes can be there. Okay, like this, uh, the lane works. The lane and link works. So if you have any notes, you can please write it down. Today I will explain the packet flow. Okay, how the packet flow and one point, and how the initialization will happen in the PCI. Okay, these are the two important things. If you want to learn PCI, these are the two important things everyone will ask in interviews. If you want to debug anything, you need this flow. Okay, first of all, we will concentrate on the packet flow. So PCI is the packet based protocol. Remember thing, PCI is the packet based protocol. Up to Gen 5, it is the packet based protocol. In Gen 6 and Gen 7, we have the FLIT protocol also. Okay, in Gen 6 and Gen 7, the data transfer happen in packet and FLIT. Okay, up to Gen 5, PCI is the packet based protocol. Okay, the data coming from the application layer, or application layer, there can be a AXI. Remember, the data coming from the application layer. For application layer, how we will come the data, either AXI or HP. It can be anything. Okay, the data coming from the application layer or nothing but device core. In the transaction layer, we are adding the header and digest. These digest are nothing but the ECRC, end-to-end code redundancy check. Okay, digest is nothing but ECRC. Data is nothing but the data coming from the application layer. That's why I told you PCI is the data transfer protocol. Okay, it's not a bus protocol. PCI is the data transfer protocol, serial data transfer protocol. PCI is the serial data transfer protocol. PCI is the parallel transfer protocol. Okay, so in PCI, data coming from the application layer, we are adding the header and digest together called as a TLP packet. That packet we are sending from transaction layer. In transaction layer only, we're appending the header and digest. In transaction layer, we're appending header and digest together called as a TLP packet. We are sending to the data link layer. Okay. In data link layer, we are appending the sequence number and CRC and LCRC. Here LCRC. Okay. In in data link layer, we're appending the sequence number and LCRC together called the TLP packet we're sending to the physical layer. Okay, in the physical layer, we're appending the start of the TLP, end of the TLP. I will give you the brief introduction next on these packets, each and every packet. Okay, uh, don't need to worry. The together packet we're sending from one device to another device through link. Okay, through link. How the data convert from serial to link? There is a flow in the physical layer. Don't need to worry. When it comes to physical layer, we can discuss about how the change will happen from serial to serial data transfer. Okay, what the same thing we did from the transmitter side. At the receiver side, we are quite oppositely. We need to do like in transaction layer in transmitter side, we are appending the STP and END. Here, receiver side, we are removing the STP END. Together, this packet we are sending to data link layer. In data link layer, we are removing the sequence number and CRC, LCRC. So this TLP packet we are sending to the transaction layer. In transaction layer, we will remove the header and the digest. Okay, and next the actual data sent from the device A application layer, we will send the data to the device B application layer. Like this, the data will flow. If someone asks how the data will flow, you have to tell like this: from one device to another device. Okay, this is how the packet flow will happen, and I will tell you the how the initialization will happen in any test case. In any test case, how the test case will works, how the test case will start. Okay, test case will start from physical layer, from down to up. Test case will start from down to up, like physical layer to data link layer to transaction layer. So I will tell you how it was. Okay, initially this is the device A, this is the device B. Both are at different places. First of all, we need to connect the devices through link. Okay, the connection and things are all happen in the physical layer. Nothing but the LTSSM states we have the connection. How the connection will happen? LTSM, we can see the connection. After connecting the device, after detecting the device A and device B, the physical layer intimate to the data link layer. My job is done. You can send the data. In the data link layer, what the thing happen? No, in data link layer, it will start sending the DLLPs. There is a flow control mechanism is there. I will tell you the small intro of the flow control. Flow control mechanism means how much space available at the device B need the information to the device A. Device A require the information of the device B, how much space is available. For suppose, if someone is point A, if someone is point B, A person want to send data to the device B person. Because A person need how much space B can have. Then only A can send the data. If A don't know the how much space available at the B, if A send, then it will block the transfer because B need to handle the data based on the space only. How much B have the space, it can take the that much amount of the data. If B don't have any space, if A send continuously packets, okay, it leads to a blocking. So delay will happen. That's why the data link layer, after the job done in the physical layer, the data link layer will work the flow control mechanism. After the flow control mechanism, we got to know the how much space available at the transmitter side and the receiver side. Transmitter is the A and receiver is the B. And also transmitter is B and receiver is A. That's why PCI is the dual simplex protocol. Means either device can send the data and device can receive the data. That's why see flow will happen both sides. This is one flow A to B and this is one flow B to A. That's why PCI is the dual simplex protocol. Either it can send the data, it can receive the data. Okay. After that, knowing the space available at the device A and device B
Guys,
through.
at least you can tell, okay, understood. Okay.
Guys, are you getting? Or if someone have any doubts, can you ask?
Can you go a bit slow, please?
Yeah, yeah.
Okay.
Are you understanding? Like, are you
Yes,
able to
yes,
take?
but bit slow. Yeah, that's it.
Yeah. So after the data link layer, job of the data link layer is done. Okay. Then they need the actual data transfer. See, in PCI, the data transfer happen in the 5 types of packets. For suppose if you want to send the data to the memory, system memory, we are sending the data to the memory transfers, memory read and write. Okay. And IO, the present generation, we are not using any IO packets. Okay. In PCI, we use the IO transfers. Present we are no one company will use the IO transfers. Okay. And coming to the config read and write, if you want to read any write or read to the configuration address, so I will tell you the why the config read and write required. For suppose a device A contain the every device contain the 4 KB configuration space. Every PCI device contain the 4 KB configuration space. To do the any transaction to the 4 KB configuration space, they need to do the transfer through config read and write. Through config read and write only, they will do the transfers. That's what the importance of the config read and write. For memory read and write, if you want to do transfer to the system memory, remember that in system memory, they will do the transfer through config memory read and write. This is the intro I will telling. Okay, when coming to the each layer, we will go to the brief. Okay, and completion. Okay, if you're sending any request, okay, you need completion, right? If you are sending any request, you need completion. For that, the completion will works and messages. In PCI, there is no messages. In from PCIe onwards, the messages comes in the picture. Okay, messages is used to it's like a one-way communication. Okay, means you are sending one message. Okay, but you're not for message you don't expect any completion. Okay, and atomic operations. Atomic operations also mostly we will not use. This is also one of the type of operations. Atomic transfers we can tell. Okay, here TLP packets. These TLP packets. These TLP packets are transferred from the transaction layer. Okay, after the job of the data link layer is done, data link layer informs to the physical layer and transaction layer. Okay, my job is done. Then you can send the actual data transfer. The actual data nothing but these are the TLP types. This is the how PCI initialization will happen. PCI initialization will happen from physical layer to data link layer to transaction layer. The packet flow will happen from transaction layer to data link layer to physical layer. This is how the flow will happen. Anyone have any doubts?
Then according to this, initialization it happens only at the receiver side.
No. Actually, initialization should happen from both sides. See, device A, device B have different places. Okay, the communication should happen through link only, right?
Yeah.
Okay, yeah, the link, how the link will connected, how, because for suppose a person A is there, person B is there. Person A want to communicate person B. So person A need the whether person B is connected or not. The connection happens through link. How the connection, how the person A know the person B? Because there is a setting voltage levels are there. In PCIe electrical path, there is certain voltage levels 0 to 3.6 voltage. Okay, when capacitor achieve the 0.0 to 3.6 voltage, the detect is happen. Okay, like this the detect will happen, so device is connected. Okay, next it need to achieve the clock means uh, synchronization should happen. If you want to send any transfer, you need the synchronization, right? If there is a proper synchronization is there, then only you can send the transfers. Okay, that's why initialization will happen from the physical layer to from physical layer only. Did you got the point?
Yeah, but I think okay. Okay, I will ask police station.
Okay. Yeah. Other any other people have any doubts?
Yeah, so this data transfers will happen in parallel from device A to B and B to A.
Data transfer serially.
Yeah, serial means you told it is dual simplex, means like at a time it simultaneously it will
See,
happen.
yeah, you're confusing the data transfers means happen through serially, but both devices can communicate at same time. Means A
Oh,
can send data transfer to B and B can send data transfer to A at same time.
okay.
Yeah.
Yeah. So in this transaction layer packet, we are sending data, right, along with this HDR
Yes,
digest
yes, yeah,
CRC.
HDR means header.
And
Yes,
yeah, again in data link layer means we are sending some other things,
sequence
right?
number and CR. Yes,
Okay. So means this is the flow basically PCI will follow. Means like
yes. Packet flow. If someone asks the packet flow, what is packet flow in the PCI? Like this only you need to explain.
okay.
Yeah. Any other guys have any doubts?
Why industry not using IO transfer?
Why? Because it is a old transfers. IO memories we don't require present. IO is IO like IO generations, like present generation. We don't need IO type of transfer, input output transfers. We need the memory only. Okay, it's outdated transfers IO. Okay, and IO transfer when we will use means if PCIe communicate with PCI, then you need the IO transfers. Are you getting?
Okay. Means
IO
PCI
memory,
communicate with PCI.
PCIe peripheral component interconnect express communicate. You want to communicate with peripheral component interconnect, then you need IO transfers because it is a older version. How the communication will happen through bridge? Okay, there is like a bridge. Okay, from if you want to connect from native to legacy, legacy is the older version. That's why the communication will happen through like that. Then you need the IO.
Means in if we will keep a PCI in EP side means legacy
Yes,
devices.
exactly,
Okay.
exactly.
Okay, thank you.
Yeah,
Well, that is fine.
yeah.
Express to express, we are not using IOs because uh, the parameter, the IOs are common, right? That's why you are not using that IO transfer.
Sorry, can you come again?
So like for express to express transfer, you told like we will not using IO
Yeah, we will not use
because the RTL is generic. That's why you are not using, or else like
because latest companies what they think there is like IO transfers when there is no development of the new features. If you the endpoint is legacy one, okay,
Hmm.
PCI one. If you want to communicate with the legacy one with the native one, then you need the IO transfers, IO memories and all.
that's what I am asking. Like if devices like both are express devices, the RTL is
Then
generic, then the ports are the same. That's
yes,
why they are skipping the step, but it is
yes.
that's the only reason, right? It's not like connections are not giving.
Not like connection. See, skipping means if the you will got to know the how the like your endpoint is native or legacy. Okay, how you will know means through enumeration. There is enumeration concept is there through enumeration. Okay, by reading the registers of the see every I told right every device contains some registers. Okay, if suppose you are the person, you contain the 4 KB memory space. Okay, in the 4 KB memory space, in the memory space contain the your features, your configuration. Okay, your native or legacy. Okay, what the transfers you support. Okay, based on reading the things you got that host or other endpoint got to know. Okay, the person can support these things. I can do transfer these things only. Did you got the point?
Yeah, in case if new IOs are added, then they will transfer, right?
Sir, can you say some noise is very slow? Can you check the earphones?
Yeah, in case if new IOs are added, they will again do the IO operation. No?
New IOs means they will not add. Present industry, there is no IO transfer will do. And everyone got the how the packet comes from software layer. I told right. See here, packet coming from the application layer. In the transaction layer, we will add the header and all. In the data link layer, see every layer contain the some job. Okay, you can note it down. I will tell the each layer features. If you have notepad or something a notebook, you can write the features of the each layer. It is very helpful for you. Okay, first of all, application layer or host layer. application layer or host layer is like a data coming from the application, means it's outside. Okay, data coming from the application means like through AXA or HP some bus protocol. Okay, means the for PCA how the communication will happen with application through AXA or HP only, right? Through that bus protocol only the data will come. So in the transaction layer, that main Java, there is some certain features are there. Every transaction layer contains some features. Okay, transaction layer contain the features like the types of packets. You can note it down, the types of packets. We have the certain types of packets in the transaction layer. Memory read write packet, IO read write packet, config read write packet, completion packet, and messages atomic operation. These are the 5 types of packets. Okay, and also another feature called flow control. Basically, flow control is the interconnection between the transaction layer and data link layer. Flow control belongs to the transaction layer and data link layer. And also transaction ordering. And also TCVC mapping, how the mapping will done. Well, like discussing on the each layer, we need to discuss the each feature. Okay. And arbitration. Okay, these are the features present in the transaction layer. In data link layer, we have the features like types of DLLP packets. We need to know the how many types of DLLP packets we have. Okay, and another one is ACNAC protocol. This is the most important protocol. Okay, if you debug on PCI, most of the test cases contain the ACNAC protocol. Data link layer contain ACNAC protocol. Okay, and physical layer contain 2 parts. One is electrical part and another one is logical part. Okay, the electrical part, the job of the electrical part is how the device is detect from one end, how the device is detected. Okay, for A and B, how the both devices are connected, how the clocks are maintained. These all things happen in the electrical part. In the logical part, we have the LTSM. LTSM is the core of the PCI. Okay, every engineer they need the flow of LTSM. Okay, LTSM contains the several states. I can explain the how the LTSM will works. Okay, later. These are the features of the each layer. Okay. Anyone have any doubt? See, data link layer contain 2 features: ACNAC protocol and DLLP package. See, messages data transfer between 2 devices. Okay. I told you, right? A flow control belongs to transaction layer and data link layer. Okay. And also data link layer contain the ACNAC protocol and the DLLP packets. Physical layer divided into 2 types: electrical block and logical block. Electrical block contain the analog things, how the devices are connected, how the voltage levels and all discussed in the electrical part. The logical part, the core of the PCA, LTSSM. Okay, link training state machine, how the link is
So
trained. Yeah,
you were telling that differential signal plus or minus the wire.
yeah,
So that happens in the physical layer.
yes. Actually, that thing happened. That thing connected in the initialization, initial of the, if for suppose if you want to run, if you initiate any test case, okay, first of all it starts with the logical part, means physical layer only. The test case will start from physical layer only. Okay, yeah. Any doubts?
Flow control belongs to both TL and DL.
Flow control, yes, belongs to both. I will tell you why it belongs to flow both layers. I can tell next. Okay, before going to that, I will explain the what are the differences there in the different generations. Okay, so I can explain now what are the differences between the different generations. Okay, you can note it down, or else we will send this word notepad, this thing. Okay, in Gen 1, Gen 2, remember this thing. In Gen 1, Gen 2, we are sending the data by 8-bit by 10-bit encoding. Okay, means for every 8 bits of data, we are sending extra 2 bits. Will only you can send the total 10 bits we will send each transfer. Okay, there is a that's why are you getting 8-bit by 10-bit encoding? For every 8 bit of data, we will send with extra 2 bits. Okay, means here 20% of extra bit, 20% extra bit we are sending with data. Means, see here for Gen 1, the you can note it, the Gen 1 speed is 2.5 giga transfer per second. Okay, are you getting? Gen 1 is the 2.5 giga transfer per second. Okay, and quickly I will open the mind share. In every interview, they will ask the difference between the different generations, and also they will ask the difference between the 8-bit by 10-bit encoding and 128-bit by 130-bit encoding. This is the compulsory question. With any years of experience, they will ask this question. What is the difference between 8-bit by 10-bit encoding and 128-bit by 130-bit encoding? So initially, for Gen 1 onwards, and we need to know the bandwidth of the each generation. If someone asks what is the bandwidth of the generation 1, we need to do like this. Okay, Gen 1 speed is the 2.5 giga transfer per second, 2.5 GB per second. Okay, and into 2 directions. I told right, PCI is the dual simplex, means both PCI is the dual simplex, right? I told before, means either see PCI is the dual simplex, means device A can send to device B and device B can send to device A. Okay, means both sides. Means we the bandwidth calculate from both sides also. That's why 2.5 giga into 2 directions. From transmitter to receiver is one direction, and receiver to transfer is the one direction. So for total 2 directions, you can take 2.5 into 2 directions by how much bits we are sending. Gen 1 we are sending 10 bits. For every 8 bits of data, we are sending with 10 bits. Okay, that's why 2.5 into 2 divided by 10 means 0.5 GB per second. For each second, we can send 0.5 GB of data. This is the bandwidth allow in the PCI Gen 1. For each direction, 0.25 bandwidth. For for the both directions, from transmitter to receiver and receiver to transmitter, both directions they have 0.5 GB per second. For one direction, 0.25. Okay. For Gen 2 means double of the Gen 1 speed. Means 5 into 2 directions, right? Gen 2 also 8-bit by 10-bit encoding. So we're sending 10 bit of data. Means 5 into 2 divided by 10, we have 1.0 GB per second. This is the total 2 directions, transmitter to receiver and receiver to transmitter. If for one direction transmitter to receiver, 0.5 for the Gen 2. Okay, from Gen 3 onwards, spec writers choose that we don't need to double the frequency, means we don't need to double the speed. Here we can double the data. We can send more data with 8 giga transfer per second. Okay, here in Gen 5 in Gen 3 onwards, in Gen 3 we will use the 8-bit but 128-bit by 130-bit encoding. Here designers will choose the here Gen 1, Gen 2, there is a wastage of bits, means 20% overhead will happen. But in the Gen 5, Gen 3 onwards, there is only 2 extra bits only is there. Okay, in Gen 3 onwards, only 2 extra bits, means for suppose if we are sending 8-bit by 10 bits, for every 8 bits we are sending 10 bits, means extra 2 bits. For suppose if you open calculator and see, for every 8 bits we are sending 10 bits, means how many if you compare with 128-bit by 130-bit encoding, means 32 bits are wasted compared to Gen 3, Gen 1, Gen 2, 32 bits are extra bits we are sending. To overhead of these 32 bits, we are sending 128-bit by 130-bit encoding. Here we are not doubling the speed. We are sending extra data with 8 giga transfer per second. We are overheading the 20% overhead in the, means we are overheading these 20% extra bits in the Gen 3. Okay, if you are using Gen 1 8-bit by 10-bit encoding, there is a 20% extra bits is waste bits we are with extra bits we are sending. But in Gen 3 onwards, we will send 128-bit by 130-bit encoding. Here bulk amount of data we are sending. Okay, so for Gen 3 onwards, we are sending in the form of
Venkatesh, can you maximize the letters? Just to click on Control plus.
Yeah.
Some more. Yeah. Okay.
See, here we are sending in the Gen 5 onwards, we are sending the data in the form of symbols. Okay, each symbol contains the 8 bits. Okay, so Gen 3 speed is 8 giga transfer per second for both directions to 8 into 2 by we are sending in the form of symbols, right? Each symbol is the 1 byte. So we are sending 16 symbols. So 8 into 2 by 8 symbols. Sorry, each symbol contains 8 bits. 8 bits per byte. That's why 8 into 2 divided by 8, we have the 2 GB per second. This is the bandwidth allowed in the Gen 3 onwards. For both direction. For each direction, the bandwidth allow is 1 GB per second. For every second, we can send 1 GB data. This much amount of speed we have. This much amount of bandwidth is allowed. For Gen 4 onwards is a 4 GB per second, similar to Gen 3 calculation. Here, speed is double. From 8 to 16. That's why bandwidth is doubled. For Gen 5, 16 to 32 giga transfer speed. That's why bandwidth is double, 4 to 8 for 2 directions. This is okay. In Gen 6 onwards, we have the 1 bit by 1 bit encoding. Up to Gen 5, we have used from Gen 3 to Gen 5, we have used 128 bit by 130 bit encoding. From Gen 6 onwards, we will use the 1 bit by 1 bit encoding. For every 1 bit, we will send 1 bit. Okay. Here, PAM. Here we have the PAM signaling. Okay. We will discuss about after that how the PAM will work. Okay, pulse amplitude modulation. This is the one type of the encoding present in the Gen 6 onwards. Okay. Here Gen 1 speed is 2.5 giga transfer per second. Gen 2 is 5. Gen 3 8. Gen 4 16. Gen 5 32. Gen 6 64. Okay. And also here these are the some differences I have noted. Okay. How if you read now, you can't understand what is the order sets and all. Later we can discuss. But these are the differences we can find after knowing the PCI. These are the differences we can find. Okay. If you read PPT also same like this only you have speeds and all. Anyone have any doubts?
Can you share that one differences again?
Yeah. This one, right?
Yeah.
Yeah. Have any doubt? Every interview they will ask the what is the difference between 8-bit by 8-bit by 10-bit encoding and 128-bit by 130-bit encoding. The easiest answer, the answer is like we are overhead the 20% wastage of bit, and compared with 8-bit by 10-bit encoding, we are overhead of the 20% of bit in the 128-bit by 130-bit encoding. Okay, here for every 128-bit of data, we are sending extra 2 bits. But in the Gen 1 and Gen 2 onwards, for every 8 bits, we are sending extra 2 bits. Means 20% wastage of data, 20% wastage of bits happen in the Gen 1, Gen 2. Are you getting?
And what about Gen 6? Then you are using 1 bit for wasting every bit.
Yeah.
For every one.
Actually, in Gen 6, you need to know the PAM for signaling. This is a type of this is a topic within the analog side. Okay. PAM for signaling is there, right? PAM for signaling will define the how the encoding happened from Gen 6. Anyone have any doubts? These are the basics, basics of PCI, how the flow and all. Okay. Next onwards, we will go through the each layer.
Can you explain once that Gen 3 calculation?
Gen 3?
Calculation, like how it was.
Yeah. For Gen 3, Gen 3 speed here for Gen 1, Gen 2, they double the speed. Okay. But here we are not doubling the speed. We are calculating for every byte. Okay. For Gen 3 onwards, there is a 8-bit transfers. Like 8 bits per byte. Every byte contains 8 bits, right? We are calculate for the every byte, because
So that is 8 bytes of transfer. That means like 8 into 2.
16 bytes we will transfer. 16 symbols. Okay. Every symbol contains the 8 bits.
Okay.
Okay. The speed of the Gen 3 is 8 giga transfer per second. Okay. Frequency. So 2 is the, for both directions we are calculating. Okay. 8 into 2 by how many symbol contains, how many bits? 8 bits.
8 bits.
Okay. So from Gen 3 onwards, symbol contain 8 bits. For Gen 1, Gen 2, symbol contain 10 bits. Did you get the point?
Yeah.
Yeah. 8 into 2 divided by 8 means 2 GB. 8 into divided by 8 means 16 by 8, right? Means 2 GB per second for both directions, not one direction. And also you need to remember that here 1x is there, right? This is the bandwidth allowed for one lane. Important point. Don't confuse, okay?
That
This is for
lane consists of like both RX and TX, right?
yeah. RX and TX, differential signals is there, right? Plus D and minus D.
Yeah.
Together called as a one lane, right? For one lane, this much amount of bandwidth is allowed. Did you got the point?
Yeah.
Yeah. This is the very important thing. Every interview they will ask this compulsory. Even when we go experienced people also, they will ask the basic difference between the 8-bit by 10-bit encoding and 128-bit by 130-bit encoding. How the bandwidth is calculated. Okay. Yeah, that's why you should know, must and should know. Yeah, any other guy have any doubts?
Yeah, if number of
this is
lanes,
One by one, can you ask?
yeah, if number of lanes increases, then it will be the bandwidth again will increase, right?
Yes, of course.
2 lanes, if
Two
we use
lanes
2
means
lanes, So then 1 GB
2 into, yeah, if you
initially.
for Gen 3, if you're using 2 lanes, okay, 2 GB into 2.
Yeah,
Each,
yeah, 4 GB per second, right? Like
yeah, for both directions.
means 4 GB from TX to RX and 4 GB
RX,
from RX
no,
to
no, no,
TX.
no, 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 not like that. For TX to RX is 2 GB and RX to TX is 2 GB. Total 4 GB.
Okay.
Here, see, here we are calculating for 2 directions. Okay.
Yeah. Okay.
And also, I will show you the, you need the real time how the test case looks like, right? Everyone need that one, right? How the test case will looks like and all. Okay, I will show you.
Yeah.
Okay, in PCI,
In Gen 4 and Gen 5, Gen 6, why you did not calculate into 2 for both TX and RX?
so here I calculated, right, 2.
Thank you.
So in real time, how the PCI test cases looks. Every engineer need the
Hello.
PCI. Yeah.
I have doubt in Gen 1, Gen 2. Like you
Yeah.
divided by 10, but here you divided by 8.
Yes.
Like as you said, like symbol size is 10 for Gen 1, Gen 2, and for Gen 3 onward, it will be the 8.
Yeah.
That thing I'm not getting. Like what?
See, actually, in Gen 1, Gen 2, we are sending 10 bit per symbol.
Okay.
Okay. But in Gen 3 onwards, we're sending 16 symbols. Each symbol contains the 8 bit of data.
Okay.
Yeah.
But here, what I'm thinking means previously, like for converting in byte, we are dividing by 8.
No, not like that. Wait, I will show you. See, is it clearly written, right? 10 bit per symbol. Okay.
Okay.
Yeah. For Gen 3 onwards, we have 8 bit per byte. Okay. I will show you the symbols, how the symbols looks like.
Yes.
Quickly, I will show you. Yeah. Yeah.
Each symbol contain 8 bits.
Yes.
In Gen 1 and Gen 2, 8 plus extra 2 bits will say a transfer.
Yes.
8 plus 2.
Yes.
Okay.
Actually, in Gen 1, Gen 2, symbol content normal data is 8 bits only. But here, Gen 1, Gen 2, we are adding extra 2 bits per symbol. Are you getting?
Yes. Okay.
Yeah. In Gen 1, Gen 2, we are actual symbol content 8 bits only. Don't remember symbol content 10 bits. For 8 bits, we are extra adding 2 bits. That's why 10 bits per symbol. For Gen 3 onwards, we are sending 8 bits per symbol only. We are not adding for every symbol, we are not adding any extra 2 bits. Okay.
So you mean that wastage is reduced in Gen 3?
Yes, exactly. That is the important thing you need to know.
Okay.
See, suppose this is the for 1x lane, this is the how the data will flow. Okay. 0 to 15 means 16 symbols. Okay. Did you got 16 symbols? Symbol 0 to symbol 16, 15. Okay. Means 16 symbols. For 16 symbol, we are adding only 2 bits right extra. Did you got the point? Someone asked, right?
Yes, each symbol containing 8 bit.
Yeah.
That's why we are dividing by 8.
Oh, yes, of course. But
Means
in Gen 1, Gen 2, we're sending 10 bits per symbol. That for every
finally we are calculating that bandwidth per symbol like that.
yes, symbol only.
Okay.
Yeah.
Here the total 16 bytes, right?
Yeah,
Venkatram?
16 bytes. The 16 bytes
Yeah,
means
no,
128, right?
yeah, got it.
Yeah. 128 into 128 divided by 8. 60. 16 symbols. Okay. First 2 bits is the extra bits. I will tell you what is the functionality of the 2 bits. Later we can discuss. Okay.
But bandwidth is the overall transfer, right?
Yes,
Then
yes.
why we are only calculating per symbol? Why not means total?
Because we are sending in the form of symbols only. Okay.
Okay.
See, in the lane, we are striping the data in the form of symbols. I will show you the how that looks like. Here, see here. Why you have asked why the calculator first bytes, right? Symbols. Here, after this is the data coming from the, see, this is the mux is there, right? Are you getting? Are you able to see?
Yes.
Okay, the data coming from these. Suppose this is the data coming from the transaction data link layer. This is the data link layer. This is the data link layer. This is the physical layer. Okay, the data coming from the data link layer. We are byte striping, means we are dividing the data in the form of byte striping. Byte striping means we are stripe the data. We are divide the data in the form of bytes. Nothing but symbol. One byte is
Okay.
equal to one symbol. We stripe the data, means we need to divide the data for each and every line. For suppose you have the 100 chocolates is there. Okay, each you have 100 chocolates. Okay, there is a 3 pipes are there. Okay, each pipe you need to send the 8 chocolates, 8 chocolates, 8 chocolates. Again 8 chocolate, 8 chocolate, 8 chocolate. Like that you need to divide the data.
Okay.
Okay, if 1x line means directly we can send the data. If it's 2x line means 2 lines are there. First you need to type the data 8 8 and again 8 8 again 8 8, like that you need to divide. Typing is happen.
Okay.
Okay. If anyone ask any doubt? Can you quickly ask? We can start the if the time is there, we can start the each layer, every layer. Start from
Here, hello.
yeah.
Yeah, here speed is common for all the lanes, right? Whether we are using single lane or all the
Speed
like.
means no. Speed is doubling the speed, right? Speed is not same. Why it will same the speed? You're asking about generations?
No, commonly like bandwidth
Yeah.
and the speed.
Yeah, speed is same for all lanes. If
Same
you're
for
using
okay.
Gen 1, 2.0 GHz, if every line is speed is same.
Okay.
Of course, it should be same only.
Yeah, that's okay.
If you're using different speed, no, one lane can transfer at one time interval, another lane can transfer at another time interval. There is a data mismatch will happen, right?
Yeah, fine.
Yeah. Prashantik, what we can do?
Venkatesh, you want to share the test case, right? Like
Yeah,
probably.
I will show you. Yeah, and I will show you the how that run log also I will show you. Actually, yeah, one thing I need to discuss. Every PCI engineer, verification engineer, if you are working with PCI, there is a terminology like you first of all, if there is a PCI test case, if you are running any PCI test case, there is a like trackers are there. For every PCI test case, there is a trackers. Okay, the trackers will give you the test case flow. Okay, I will show you the trackers and all. Okay, but there is a trackers run log. Okay, these things, and also if you want to check the result in the, like if you want to check the result values, you need to check in the wording. These are the things that happen in the you need to take care. Okay, and also for suppose this is one of the test case. Okay, this test case, if you're working any PC test case, they will give the brief introduction of the what is the test case behavior. Okay, these are the test case we need to expect in the, these are test case behavior is expecting. Okay, they will give the this test case works on which speeds, Gen 6, Gen 5, Gen 6, Gen 7, so far suppose. Okay, there is a one test case. The test case working on the Gen 5 speed, Gen 6 speed, Gen 7 speed, means it can support Gen 5, Gen 6, Gen 7. Okay, connection type. How the data will flow from one endpoint to another endpoint, like one RC to endpoint. How the data flow means either serial type and pipe. Okay, there is a pipe is there in the PCI pipe connection. There is a pipe connection means PCI to PCI, like endpoint to endpoint, there is a connection like pipe connection. Okay, we can discuss later. This is advanced level. Then we can discuss the pipe concept and also protocol layer. If this test case belongs to which protocol, which layer, whether it's transaction layer or the data link layer and the physical layer, they will give you the information. Okay, this test case belongs to physical layer, and they will give you the purpose of the test case. What is the purpose of the test case? Okay, and also they will give the checklist item. This checklist item nothing but the in the test case we need to check this behavior. Okay, and also spec section. If any test case, they will give the spec section, means this test case matter and all you need to check in correspond to this spec section. You need to refer this spec section in the specification. This procedure will tell you the test case how the procedure will happen. Okay, and also I will show you the how the test case how the test case will looks like. These are the tracker files for every test case. There is a tracker files is there. If you want to check in the if test case belongs to physical layer, no, first of all you need to check the physical layer flow, how the physical layer flow is happened. Okay, I am opening the physical layer flow. LTSM flow I will open. I told it how the PCI visualization will happen. Now I will show you the okay. See, this is the test case. How the test case is looks like how the test case will start. Test case will starts from LTSSM detect. I told right. Detect means these are the states happen in the physical layer. Test case will starts from detecting the device. Okay. Next, it configure the device. Okay. Next, L0. L0 is the I told right. L0 is the like active state. We need to send the actual data. Means up to configure idle, the link training will happen. The link is trained. My job of the physical layer is done. Then you can send the actual data transfer in the L0. Okay, or if you want to change the speed from Gen 1 to Gen 2 or Gen 2 to Gen 3, then you need to go to the you need to retrain the link to new speed. I will tell you that while discussing about the LTSM, we can discuss about the how the speed change will happen in the PCI from one generation to other generation, how the speed will change. We can discuss later. Okay, like this by using these trackers and all, you need to debug the things. Okay, these are the I told right. These are the symbols. Okay, these are the order sets. We are configuring. We are sending from one day. This is the device A. This is the device B. Device A sending. Device B sending. Device A sending. Device B sending. Device A sending. Device B sending. Mutual communication will happen. Okay, like this the flow will happen. This is the device A. Transmitter receiver. Transmitter is sending. Okay, receiver is waiting. Sometime receiver will send. Receiver will send like this. The detect and will happen. Device is detected and the clocks and all it will be there. Later we can discuss. Okay. But real time scenario, the test case, the scenarios you need to debug like this while seeing the trackers and all. If you want to check the tracker, this is the pi tracker means the behavior we are checking in the pi layer. Or if you want to check in the data link layer, then you need to open the data link layer tracker. Here, data link layer tracker will be there. DLL. These are the data link layer trackers. Okay. Or if you want to check in the TL layer, this is the transaction layer. Okay. Like this, the things are happen. Things will be there. How the flow will happen.
All layer have different tracker.
Yeah, every layer have every different trackers. Okay. Yeah. If anyone have doubts, can you ask?
In transition layer tracker, also like half part is for send transmitter and half part of receiver. Like means
Actually,
the login.
if you want to check the transaction layer tracker, what are the things you need to check means there is a in transaction layer I told you, right? The packet flows, there are different types of packets initiate from the transaction layer, right? There you can find the memory, right? Memory packets, config packets, okay, messages. These are the packets we flow. We can check in the transaction layer tracker, TL tracker. For DL tracker, data link layer tracker, you can check the ACNAC protocol flow. Okay, DLL packets we can check in the DL tracker.
The flow will be similar like in as you share the screen physical tracker.
Like that.
Like half part is from transmitter, half of the part from receiver. Means both will print at the same time like that. It will happen.
Both means for suppose.
Means sender and receiver.
Yeah,
like.
I will tell you. If test case, okay, there is a test case. Okay, the test case contain the. For suppose there is a test case, the data is transferring from the RC root complex to endpoint. Okay, then the flow will happen from one side only. Okay.
Okay.
Flow should happen one side only because you're doing transfer from RC to EP, root complex to endpoint.
Yes.
Okay. Then that the flow is there in like a RC to EP only, not EP to RC. Both sides will not be there because the test case purpose is like from RC to EP only. Okay. Based on the test case flow. Okay. Flow in the tracker. If any error is there, you need to check the each and every test case. Suppose there is an error you got for the data link layer, you need to quickly open the first. You need to check the file layer. If for anything, you need to check the file LTSM flow, how the LTSM is working. Next, you need to check the data link layer and physical TL layer based on the test case purpose. Okay.
Yeah. But
like this only.
In case like we can get the data from the EP side as well.
Yeah, EP side. So EP side is there means you need to check the EP tracker.
Okay. Means separate tracker for the TL layer. Okay.
Yes.
Okay.
See here.
Venkatesh, are you sure? Okay.
Yeah. See here. See, did you remember TL tracker for the EP, TL tracker for the RC? Okay.
Okay. That thing I want to know. Okay.
Yeah. Pi tracker. This is the pi tracker means overall RC, TL and like transmitter side and receiver side. Okay. This is a physical layer for the from the RC side. This is a flow from the EP side.
Okay.
And also test case like this is the driver tracker also. Normally UVM driver tracker also will be there. Okay. UVM driver tracker. Okay, RMux and these are the internal things we can later you will get to know. Okay. Yeah, Prashant is done from my side.
Okay. So any doubts are there from remaining? Can you explain some more features of like any remaining topics? We have half an hour extra.
Yeah, I can quickly explain the TL features.
Okay. Yeah.
Can I start the TL layer?
Sure.
Yeah. I will start the TL layer. Today we can discuss about the now we can discuss about the transaction layer. Okay, transaction layer TL packets. Transaction layer packet. How many packets are there in the transaction layer? Okay, each packet can the specification of the each packet. So each TLP contains the header, data, and digest. Okay, the digest is nothing but the ECRC, end-to-end code redundancy check. Okay, data is the data coming from the application layer. Header we are adding in the transaction layer. So this is the header fields. This is common for every packet. Now I am telling the header fields specification. Each field specification. Now I can tell transaction layer header specification. Okay. See, this is a format. Okay, when you're sending any packet, there is a format is there. Format field represents the whether you are sending which type of packet, either 3D word or 4D word. Okay, remember thing, 1D word equal to 4 byte. Okay, 1D word equal to 4 byte. Format will tell the which D word of the header. If format equal to 000, it is a 3D word header. Later you can discuss, you can learn these things and all. If format is 000, 3D word header. If format is 01, it's a 4D word header. Okay.
What is the D word?
What?
What is the D word?
D word is the size.
Size of the
D word
packet.
represents the not size of the header. Header. Are you getting? D word is the size of the header. 1 D word equal to 4 byte. Okay.
Okay.
Yeah. And 10 is the 3D word with data. Okay. Means if you're sending any memory write means with data we are sending. If you're sending memory write, like the scenario, you need the 3D word with data. The encoding is 10. 010. The MSBT is always 0 from Gen 3 up to Gen 4 it is 0. From Gen 5 onwards it will be used. Okay. And 11 is the 4D word header with data. Okay, like this the format, the encoding will be there. So format will represent the header size. Okay, and also if you're sending read or write, if you're and I will tell you, if you're doing any write operation, you need the with data, you need to send the header with data. Format should be 10 or 11. Or if you're sending any read, you need to send 00 or 01. Okay, like this the format is defined. And a type will represent the type of the packet. Which type of TLP packet? Either memory packet, okay, memory packet with data or without data, or memory log transfer, IO packet, messages, config packet, config read or config write. Config, we have two types of configs. Okay, one is config 0, config 1. Okay, and like this type will define. Okay, and before going to discuss the TLP packets, we need to discuss the configuration space. This is the basic concept present in the PCI. Okay, configuration space. This is a very important topic. I will tell you the configuration space. Okay. Here, config space. If the device type is, for suppose, if the device is endpoint, we will use the configuration space of the type 0 header. If the device is root complex or switch, configuration is a type 1 header we will use. Okay. Are you getting? Every device, every RC, every endpoint, every switch or bridge contain the 4 KB memory space, 4 KB configuration space. Why the space is required means if you want to do any transfers, any features, if you want to implement any features and all, it needs some memory space. Okay, that memory space is nothing but configuration space. Okay, that all features are developed, that all feature register information are stored in this configuration space. Okay, the operation should control by the configuration space only, every feature. So we have the two types of configuration space, type 0 and type 1. Type 0 contain the type 0 header field is looks like this. Okay, type 1 header field is looks like this. In type 0 header, so here configuration space is the for PCI we have the 256 byte of configuration space for PCI. Okay, for PCIe contain the 4 KB configuration space. PCIe contain 4 KB configuration space. For PCIe contain the 256 byte space. Okay, so in PCIe we have the extended configuration space, nothing but the 960 dword is the extended space we are getting in the PCIe. So configuration header will give you the information on the basic information, whether the, for suppose there is endpoint is there, this endpoint belongs to which vendor, what is the device type, what is the status of the device, what are the operations we can do. Before someone asked, right, how you got to know whether this memory is supported or IO is supported? No, in the command. Okay, in the command there is a encoding is there, some encodings are there. By reading that encoding, you got to know this is support which type of transfers. Okay, memory, IO, messages and all, we got to know by the command controlling. Okay, status will give the status of the device. This different specification is there, you can read. Header, this header will give you the whether this device is endpoint or switch or bridge by reading the header. Okay, how you will read this configuration space? Through config transactions. I told, right, in the TLP packet we have the config read write packets. Through config read only you got to know this information. This is like a exa read. Like config read only you will read the information of the config header. Why the configuration space is required means if you want to implement certain features, you need some space. Through the space only the controlling will happen, everything will happen. Okay, by this configuration space only you need to implement the each and every feature. So configuration header is common for every generation. PCI compatible space is coming from the legacy device also. PCI compatible space is accessible by legacy PCI software or PCIe enhanced configuration access mechanism. Means up to configuration capability space for legacy devices also have configuration header, configuration compatible space. But legacy devices, older versions, we don't have extended configuration space. For PCIe only have this space. Okay, PCIe have this space. PCI up to PCI we have this configuration header and capability space. Okay. Are you getting? Or if you have any doubts, can you please ask?
Venkatesh, can you explain the root complex block diagram so that we can close the session today? And remaining the concepts we will start tomorrow.
Yeah.
Just give you an overview on switch. I mean root complex and switches connection.
Yeah. See, root complex is the mediator between the processor and the endpoint. Okay. So the root complex can only initiate the config request. Note the point. There is two important points. Memory requests are initiated by the processor. Memory transaction can be initiated by the processor, but config transactions are initiated by the root complex only. Okay. The processor generally unable to perform the config read and write transactions directly because it can only generate the memory and IO request. So root complex can only generate config transaction, but for memory transaction IO transactions generally initiate it will requested by the processor only, and we will see the flow of the root complex to endpoint. Sandeep, do you have any PPT on root complex?
Yes, I have. Just a second, I will share.
Yeah, I have. Yeah, sorry.
Okay.
Yeah. See, root complex is the mediator between the processor and the endpoint and switch. Okay. Root complex can only, it's like a host. Root complex can only control the every functionality of the endpoint. Also, root complex can control endpoint functionality and the transaction, the commands like the request coming from the processor also. Okay. It is like interconnect between the processor and the endpoint. Okay. Root complex, for suppose here, root complex initiating one memory write request from processor onwards, it is initial memory write request. Okay. If there is multiple endpoints is there, then you need the switch. The functionality of the switch is if you have multiple endpoints, the flow will happen through switch only. When the switch is required means if you have multiple endpoints, more than one, you need switch. Okay. So like I will tell you the example of the memory write transaction, how the thing will happen. See, processor is giving instruction to initiate the memory write request to the root complex. Okay, by reading the by enabling the configuration header in the header present in the root complex, then it will enable the memory write transactions. Okay, it will initiate memory write transaction to the this endpoint through switch. Okay, this packet will go to the switch to switch B to this endpoint. How the flow will control means there is a routing concept is there. Okay, routing concept, by the routing concept you got to know the address of this endpoint. Okay, by routing concept only it will point out the transaction to here or here. By routing concept only the packet will flow. Okay, for memory write transaction, the transaction happen based on the address. Config transaction, that transaction happen in the BDF number, bus number, device number, function number. Like the packet will routed from root complex to endpoint through switch. Okay, this is the scenario like we have from this transaction from root complex to endpoint. If even endpoint also can initiate the transaction, that's then also it will be there. Endpoint can also initiate the transaction. If endpoint initiate the memory write transaction, okay, then endpoint to this one, this switch to this switch to root complex to system memory. Okay, system memory nothing but the memory mapped with the root complex. Like this, the thing will happen. Things are there. Okay. See how the transaction happened for the system memory like this. Yeah, Prashant is done for today.
Yeah, these things we will discuss more detailedly tomorrow.
Yeah.
Transactions and all. Okay. So whatever left for the week one, second, whatever the remaining sessions are there, we are going to cover in the second session tomorrow. Okay.
Tomorrow onwards, we will cover the transaction layer types of packets. Okay, and the enumeration concept. You see, enumeration is the important concept for every test case. We need the enumeration concept will be there. Okay, enumeration concept we need to discuss. After discussing of the enumeration concept, we will discuss the TLP types. Next, we need to discuss the flow control. After this, the TL layer will be over.
If you compare this picture that you showed, the root complex with the other one, where inside that, where will these transactions happen? The application, yeah, this transaction data link and physical layer packet transactions,
Yeah.
where will happen in that other picture?
See, actually, these three layers are the red.
Yes.
These three layers contain the every port. For every port of the device contain these three layers. Okay, I will show you that picture. Yeah, I will show you. Wait a minute. They will be there.
Yeah, this one.
Yeah, no, wait. I will show you that picture. I got what you are asking. See, for suppose this is the root complex. Okay, this is the downstream port. This is the upstream port. Okay, this is the downstream port. This is upstream port.
Okay.
Okay, this downstream port contain the three layers. This upstream port contain the three layers. Are you getting?
Okay, so
this downstream port contain three layers. From transaction layer, data link layer, physical layer, data link layer, transaction layer. Here contain the physical layer, data link layer, transaction layer. Here contain the physical layer, transaction layer. Every port contain three layers.
okay, so this is like the switch, the one below the root complex.
Yeah, it's a switch. If you have multiple endpoints, then you need the functionality of switch.
Okay, so at every point, the three layers at every point. Okay.
Yeah, compulsory.
Okay, and the flow happens from physical to data link to transaction.
Yes. One port of the transaction layer to data link layer to physical layer, and physical layer to another port of the physical layer to data link layer to transaction layer, transaction layer to application layer. Next, transaction layer to data link layer to physical layer. Like that, the flow will be there. Because physical layer to physical layer connection will be there. Then only the device is connected, right? You got to know, okay, device is connected from one point to another point. By there is a voltage level is there. They need to maintain some voltage level. When the voltage level is maintained, the device will be connected. Okay. Yeah.
Any limitation on how many number of switches would be connected to root complex?
32. 32. You can note the maximum number of buses. We have 256 buses. Okay. Switches is 32 switches or devices. Okay. Endpoints functions is 8 functions. Every endpoint can connect 8 functions. Okay. Every device is like how many number of devices means 32 devices. Number of buses is 256 buses. These things we got to know from the enumeration concept. Next we will cover the enumeration. By enumeration concept, you got to know the how many devices, how many switches, how many functions will be there. There is a BDF is there, bus number, device number, function number. Every root complex switch or endpoint contain the BDF number. By that number only the routing will be happen for IO config transactions. If it is a memory transaction, the routing will be happen based on the address. Okay. Next we will the concept will be that one only.
Thank you.
Yeah, Prasanti, I'm done from my side.
Okay, guys, any other doubts? We have 8 more minutes.
Like I want to know about initialization. What is like?
Initialization.
No, I understand the initialization, but my question is that like these devices are dual simplex. You told, right?
Yes.
The initialization it happened from physical layer to transaction layer, right?
No. Physical layer to initially starts from physical layer to physical layer.
It's link initialization.
Yes.
Physical
Physical layer to physical layer to physical layer.
Receiver physical layer to transmitter physical layer to receiver physical layer.
Yes.
And like tomorrow, if possible, like could you explain detail about that configuration space?
Configuration.
Configuration space, like you told, right?
Yes.
Like,
Yeah. Because I will. Next concept will be the configuration space. Okay. If I will give you the small intro of the configuration space. For suppose if okay. For suppose if there is a man. Okay. A man can do some functions. How the function will be controlled and handled by the configuration space. Like that, really, if device want to do certain functions, the functions and features are controlled and handled by the configuration space only. Okay, every devices contain the configuration space. If it is a PCIe, okay, PCIe Express, it contain the 4 KB configuration space. If it is the PCI, contain 256 byte of configuration space. Okay, in detail tomorrow we can discuss what is the config header, what is the compatible space, what is the extended configuration space, and later we can discuss about the enumeration concept.
this
Okay.
is the memory space that is present in the device, or is like it present in the protocol packet itself?
Every device, no, not packet, every device it contains the space, separate space.
Okay. Like
Okay.
inbuilt memory.
Yes, compulsory. The vendor or the manufacturer will give the space. For suppose if some vendor like in implementing the like providing the PCI devices, it contain the they will give the configuration space only.
Any other doubts from girls?
Venkatesh, can you just summarize like what today we have gone through? We will get recording a little bit late, right? Till that, like we can go through the mind share and we can cross.
Actually, today we have gone through the basic packet flow. Okay, how the packet flow happen from one layer to another layer, and also how the initialization will happen in the PCI. There's the two topics we discussed: packet initialization and protocol initialization. Packet initialization nothing but the packet flow. Okay, and protocol initialization means how the PC when the transmitter and receiver is there, how the working will be start, from which layer onwards it will starts working. Okay, I explained that physical layer it will connect, first it will detect the receiver or transmitter is present or not. Next it will inform to the upper layers. Next inform to the transaction layer. Like that the flow will be there. This is the basic flow I have explained. Later from tomorrow onwards we will see the basic concepts of the enumeration. How the see here in the physical layer we got to know the physically it is attached. Okay, physically it is connected, but it need the what is the configuration, like what is the configuration of the each space, each device, we got to know by the enumeration concept. Tomorrow we can discuss about the enumeration. By enumeration concept, we got to know the software will read the enumeration concept. Okay, by reading that config transaction, we got to know the what are the features it can support, device or endpoint or root complex support. Okay, by that configuration, we got to know how many devices are connected to the fabric. Okay, in the motherboard contain PCI. Okay, but PCI contain how many devices are connected to the root complex, and this software things and all we got to know by the enumeration. And also we can discuss about the configuration space like each for every configuration space, what are the things are there, what is the use of the header, what is the use of the compatible space, what is the use of the like extended configuration space. Okay, like this we can discuss tomorrow.
Okay, thank you.
Okay. Yeah, thank you, Venkatesh. We can start next session tomorrow. Yeah. Thank you all. I will share you the document, the official PCIe document to everyone. You can access.
Initially we can share the mindshare document of Gen 3. Later we can share the Gen 5 onwards. Okay. Gen 5 and Gen 6 you can share later.
Okay.
See, by mindshare only everyone will have the good understanding. Okay. By reading mindshare only everyone will get the good understanding of the PCI. It's easy to understand. It's a readable. Okay. The terminology present in the mindshare is very easy to understand the things compared to other protocols and all.
Okay, Venkatesh will follow the same. Okay, then I think no doubts from everyone. Okay. So if you have any doubt, you can note down and you can ask in the group also. These mentors are available in the group. Okay. So we'll meet tomorrow. Thank you all.
Thank you, Venkatesh. Thank you, everyone. Bye.